In this problem, we will see a conjunction, which will arise right from the statement of the problem itself. And here it is. Prove that for all integers a and b, there is an integer c such that a divides c and b divides c. Let's think about what that c might be for some various pairs of values for a and b. If, for example, we let a be 4 and b be 6, then well, we're looking for basically a common multiple of those two integers. And one thing that would work is 12, right? 4 divides 12 and 6 divides 12. But there are lots of other things that would work as well. For example, we could do 4 times 6, which is 24. And 4 and 6 both would certainly divide 24 as well. And in general, if we take, for example, some relatively prime integers, like 3 and 5, which have no common factors other than 1, and I suppose -1 if you're counting the negative integers, in that case, the sort of best we can do might be 3 times 5, or 15, right? So it seems like in general, if we let c equal a times b, that will always work. Okay. So we'll see how that comes to play in our strategy as we go through the logic here. Okay, so here's our goal. For all integers a and for all integers b, there exists an integer c such that a divides c and b divides c. And the first thing we should do is deal with those universal quantifiers. We can let a and b be arbitrary integers. So we get those as goals over here, as givens over here. And our new goal is this existential statement. And to prove that one, we need to decide what c should be. And we just said that we're going to let c equal a times b. Okay. So that becomes a given. And then we're going to have to prove that c, defined that way, is in fact an integer, and that a and b do both divide it. Okay. And it's going to be handy to write c equals b times a as well in a little bit. And that follows from the previous line just by commutativity of multiplication of integers. All right. Now, we can take care of the first one of these goals real quick by just noting that if a and b are both integers and c is just the product of the two, then c is an integer as well, because integers are closed under multiplication. Okay. So that takes care of that one, and we are left with the other goal, which is a conjunction, and so we can split it into two different goals. Okay, now we should think about the definition of this divide symbol, and what we get is this, right? A divides c means that there exists some k in the integers such that c equals k times a, and similarly for b divides c, and I'm going to use a different dummy variable because those could well be different integers. And we're pretty much done now, because if you look at these two givens, they give us the second goal, right? This L such that c equals L times b would just be a, and we know that a is an integer, so we have such an L. Whereas the other two givens give us the other goal, right? We have a k in the integers such that c equals k times a, and that k is nothing other than b. And so that's the logic. Let's try and write up this proof. The first thing we did, remember, was to let a and b be arbitrary integers. So I'll say let a and b be arbitrary integers. And then to deal with our existential quantifier here, we had to say what c was going to be, and we picked a times b. And we were immediately able to get this goal from these three givens, which left us with that goal. Okay, so let's add that in here. I'll say let c equal ab, which is an integer, and making note of this goal being satisfied. And it remains to show that a divides c and b divides c. All right, and then how did we get there? Well, we split up that conjunction into two goals, and then we wrote out the definitions, And in order to get this one here, we used the fact that c is a times b, where a is an integer. And that got us that b divides c. And so let me just comment about the other one as well. From these two givens, we got that this is true, namely a divides c. Okay, and so I am going to, I said I was going to show a divides c, so maybe I'll comment on that one first. So because c equals ba, and b is an integer, we have that a divides c. And similarly, because c equals ab and a is an integer, we have that b divides c. And those are the two things we needed to prove. So we're done.